Hey guys, so today we're going to be talking about how to convert using moles. Now, in particular, what we want to be able to do today is convert between moles and the number of particles. And when I say the word particles, I could mean atoms, I could mean molecules, I could mean electrons, I could really mean anything. So when I say particles in a chemical sense, it really is a very wide open kind of description, and it's really determining based on the context of the problem. So we're going to do this starting with some example problems, and then you're going to do some practice on your own at the end. So the first thing we need to remember, and this was originally presented in the Unit 0 videos, is what Avogadros number means and what it really represents. So Avogadros number 6.02 times 10 to the 23rd represents the number of particles within a single mole of any substance. Now we can use Avogadros number for anything relative to a mole. So again, I used it to kind of describe the number of eggs in the past. So we say a dozen eggs. What it really means is it's just simply a word to describe a number. A mole of anything is 6.02 times 10 to the 23rd of that thing. So our conversion factor here for this in particular is going to be Avogadros number, and it's a number that you absolutely have to have in the back of your pocket at all times during this course. All right, let's do a practice problem first. Now in this practice problem we're being asked how many atoms of helium are present if we have 3 moles of helium in a sample. In order to do this, we're going to have to start by writing the number we're given, 3 moles of helium atoms. Now we're going to use a conversion factor here. Remember, the conversion factor between particles and moles is Avogadros number, 6.02 times 10 to the 23rd particles per mole. Now in this context, particles is represented by atoms. So what we're going to write is instead of particles per mole, we're going to write atoms per mole. We need moles to cancel, which means it's going to go on the bottom. Therefore, atoms is going to go on the top because we're trying to convert into atoms. As you can see through unit analysis, our moles of helium cancel. We convert into atoms of helium, and we end up by multiplying across the top and dividing across the bottom, get our answer of 1.81 times 10 to the 24th helium atoms. So this is how we're going to convert from moles into particles. All right, now I want you guys to give this one a try. So here we have a question that's asking us to convert from 8.705 moles of tin into the number of atoms present in the sample. So take a minute, pause the video, solve this on your own. If you get stuck or get an answer, all right, unpause the video, we'll solve it together. Keep in mind how many sig figs we have. Try to match your number of sig figs in your answer to the number of sig figs I have here in this problem. All right, so take a second. When we come back, we'll solve the problem together. All right, now that you've had a second to solve the problem, let's do it together. So we're going to start by writing out the number we're given, 8.705 moles of tin. Now, we're going to convert using Avogadros number. We want to get it from atoms or from moles into atoms, which means we need to have atoms on top, moles on the bottom. We multiply across the top, divide across the bottom. Moles of tin cancel with moles of tin. We end up with atoms of tin, and our answer is 5.420 times 10 to the 24th atoms of tin. Remember, 4 sig figs present in the answer because there are 4 sig figs in the original problem. All right? In the next problem, we're going to do an example to show you going the opposite direction. All right, guys. Now let's do a practice problem together where we're going to convert, instead of from moles to atoms, from particles into moles, or from atoms into moles. So here we have 2.34 times 10 to the 18th atoms of sulfur. And I need to figure out how many moles that is. In order to do this, we're going to use the same conversion factor, but we want to make sure we're using it in the right way. So we're going to start by writing what we're given. Now in this case, we need to cancel the number of atoms, which represents our number of particles, and we need to get into moles. This means we're effectively dividing by Avogadros number, 6.02 times 10 to the 23rd. We multiply across the top and divide across the bottom. Atoms of sulfur cancel. We end up with moles of sulfur, and our answer is 3.89 times 10 to the negative 6 moles of sulfur. 3 sig figs in our answer because we have 3 sig figs in our original question. All right, guys. So now I'm going to have you try a really challenging problem on your own. Now in this problem, I give you the fact that we have 2.375 moles of carbon dioxide, and I want you to find the number of oxygen atoms in this sample. Be really careful with unit conversions. Make sure you track your units carefully. All right? Pause the video. Give this problem a shot. When you unpause the video, we'll go through it. So again, you want to unpause the video once you come to an answer or get stuck, and we'll go through it together. All right, so this was a challenging one. Now that you've had a chance to try it, let's solve it together. We're going to start by writing out the value that we were given, which is 2.375 moles of carbon dioxide. Now here's where it got tricky. We need to get to atoms of oxygen, but we're right now in moles of carbon dioxide, so we actually have a couple of steps to go through here. The first step is we need to figure out how many moles of oxygen there are in every mole of carbon dioxide. So what we're going to do is we're going to cancel moles of carbon dioxide and convert to moles of oxygen. Now the subscript 2 in CO2 means that we have 2 atoms of oxygen in every 1 molecule of CO2. This also means we have 2 moles of oxygen in every 1 mole of CO2. So that's what we're going to do. We're going to use that as our conversion factor. 2 moles of oxygen for every 1 mole of CO2. In this case, it's simply moles of O. We're not talking about the diatomic form of oxygen. We're talking about here the atom. Next step, we need to then use our conversion factor to go from moles of oxygen into atoms of oxygen. This is where Avogadros number is going to come in. We want to convert out of moles and into atoms, which means we're going to multiply effectively by Avogadros number. What we have is an answer of 2.86 times 10 to the 24th oxygen atoms. So 4 sig figs in our answer because there are 4 sig figs in our original problem. You make sure as you go through that all of our units cancel effectively and give us the unit that we want to finish the problem with, which is atoms of oxygen. All right, guys, so that wraps up today's video. Let's do a quick recap. Today we learned how to convert between the number of particles of a substance and the number of moles of that substance, and the other way around as well, going from moles to particles. Now, to do either function, we used Avogadros number, 6.02 times 10 to the 23rd, as our conversion factor. I'd like to thank Lucia Vaccaro for writing, filming, and editing this video. Thank you guys so much for watching. I'll see you in the next one.